Welcome to a small session that we will be talking about the valencies and valencies, chemical formulae, and some equations that need to be balanced. Thank you. You can invite a friend to join us. Thank you. So here comes the subject. But before then, allow me give a certain question so that we can handle it from this perspective. Therefore, the question will read like this. Lithium has two isotopes. Lithium has two isotopes with mass number 6 and 7. Mass number 6 and 7. And we are told if the relative atomic mass is 6.94, then determine the percentage abundance of each isotope. In this case, we shall handle it in two formats. Therefore, now you can start with the first one. Let the percentage abundance of mass 6 be P%. It means that the one for mass 7 will be 100 minus P%. And then we say that our relative atomic mass of 6.94 will be given by the mass of 6 times its percentage abundance of P% plus mass of 7 multiplied by its percentage abundance of 100 minus P%. Then you divide by 100. We can do away with 100 by multiplying through with 100. Therefore, the left-hand side becomes 694 is equals to 6P plus 7 times 100. Now we are opening up the brackets. Becomes 700 minus 7P. From here, we group the like terms together. 700 to shift to the left-hand side becomes 94 minus 700 is equals to 6p minus 7p. Therefore, in this case, we'll have a gap of negative 6 is equals to negative p. Therefore, our p becomes 6%. There is something that we need to understand. Now, the 6% is the one that we awarded to the mass number of 6. But things here are different. I can give you the NB. The mass, the least mass number, the least mass number of an isotope is awarded the greatest percentage. So now, from this case now, we say that, therefore, mass of 6 will be given the greatest percentage, which is 94%, and the mass of 7 will be given the least percentage, 6%. Keenly. Then now we can move on now to the subject of the day, where we were to talk about valencies. And therefore, we know that we have different valencies of elements. For example, if you are told, give the valency of the following ions. We have magnesium. Its valency will be 2. Maybe we have chloride ion. The valency here will be 1. Maybe we have something like copper 1. The valency here is 1. Something like copper 2. The valency here is 2. If you are given the element itself without forming ion, something like copper metal, the valence of this one is 0 because it has not undergone the transformation to form an ion. We're also changing from the solid state into the ion state. Therefore, now we can proceed to formation of that is to do with chemical formulae. Then now from the chemical formulae, we'll reverse back to extracting of valencies. Here we go. You'll say that for us to form sodium chloride, okay, you can say sodium reacting with chlorine, then you're going to form sodium chloride. Then from here, you must write in chemical formula. Therefore, this one, we are interested in this part. For us to form sodium chloride, then we must have sodium ion. And since it is of valence 1 and it is a metal, we are going to give it this sign. Then plus chloride ion, like this. So that now we can form the sodium chloride in that manner. What happened here is that sodium ion and chloride ion, this is of valence 1 and this one is of valence 1. Therefore, during the formation of the salt, then they exchanged their valencies. And because it is 1 versus 1, that is why we can arrive at this formula without stress. Now we may proceed to another example. And this will be of something to do with magnesium and oxygen. Therefore, we can have magnesium plus oxygen. Let me write in words so that because the last part that will be addressed will be the product side. So it is magnesium plus oxygen. Then in this case, we get magnesium oxide. We are not interested with this part. This part will be interested with it later on when it comes to balancing. But now we are focused on the chemical formulae of the product. Therefore, for magnesium oxide to be formed, we must be having magnesium ion and the oxide ion. Therefore, we'll have magnesium, which is valence 2. Therefore, its cation is written in this way. It must combine with the oxide. Oxide is written like this, so that we arrive at now magnesium oxide. But how do we arrive at MgO? Magnesium is valence 2, while oxide, this one is also valence 2. They exchange their valencies. After exchanging, then we'll have a common 2, which means that if they cancel out, then we'll have MgO, like that. Let's have something that can give us something like aluminum oxide. Aluminium plus oxygen, then here will be ending up to aluminium oxide. In this case now, we will be interested with the formation of the product. Therefore, it will be aluminium ion or cation, which is written as this, combining with the oxide ion like this, so that we can get aluminium oxide, which is written like this. But now we want to understand how do we arrive at Al2O3. Then we'll say that aluminium is valency 3, while the oxide is valency 2. Then during the combination, they exchange their valencies. Therefore, aluminium obtained the 2, while the oxide obtained the 3. And that is why you can see it in this manner. Now if I proceed to the next one, we still have what we call radicals. We have radicals, a group of elements that react as a unit. Therefore, now let's look at the next format, where we'll have to write something like how do we get sodium carbonate? Formation of sodium carbonate. This will involve a sodium ion combining with a carbonate ion in that manner, so that now we can get sodium 2, and then we have a carbonate in this manner. Let's now analyze it. Sodium ion is valency 1, while the carbonate, which is reacting as a unit, which we say it is a radical, is valency 2. Therefore, during the formation of the final product, they exchange their valencies. And that is why we'll be able to arrive at this. Therefore, sodium picks the valency of 2, and the carbonate picks the valency of 1. Let's have a scenario where we have a radical with a valency of 1. Let's have something to do with formation of magnesium nitrate. Therefore, it will be magnesium ion combining with the nitrate ion, and in this case, will form something. Magnesium is valency 2, while nitrate is valence 1. Therefore, during the swapping or exchanging of the valencies, then we'll arrive at magnesium picking this 1, while the nitrate picking the 2. But because the nitrate is reacting as a unit, therefore, we need to enclose it into brackets. Therefore, magnesium will pick 1, whereas the nitrate will pick the 2 in this manner, like that. So now I'll give some of the examples where you are asked. Give the valencies of the cations and anions give the valencies of cations and anions in each of the following. In each of the following compounds. Then the first one, we have zinc sulfate. Number two, we have magnesium carbonate. We have number three, aluminium nitrate. And we have the last two, where we have A2B, we have X2Y. I think you can start from down here, moving upwards. So we want to understand what will be the valency of X. Since it is on the left hand side, it means that it's the one that is carrying the cation side. Therefore, we can start responding it. We reverse. How do we land at this? X and Y. Now you can see X is having 2 here, meaning that it obtained these 2 from Y, meaning that Y is of valence 2 and X is of valence 1. So the moment they exchange their valencies, that is why they were able to form this. Therefore, we can say we'll be having the cation, which is X. We have said that it is positive, it is of valence 1, meaning that it is written like this, and we can say it is of valence 1. Whereas Y, which is having a valence of 2, will be an anion and can be written like this because its valency is 2. Let's get to part D, where we have A. So how do we arrive at A? It means that we had A and we had B. Therefore, B, since is having 1 from the compound and A is having 2 from the compound, it means that A obtained these 2 from B. Therefore, this one was 2 and A was 1. Therefore, during the exchange, they were able to form this. Therefore, I can write A was the cation, A positive, whereas B was the anion, like this. Therefore, with the valency of 2, with the valency of 1. We have now the aluminium nitrate, magnesium carbonate, and we have the zinc sulfate. Then we can start with the zinc sulfate. This one is written as zinc sulfate like that. If we break down this one, it will be of a cation, that is an element, and then we'll have a sulfate, which will be a radical. Therefore, we know that zinc is valence 2, whereas sulfate is valence 2. So this is 2 and this is 2. That's why they just cancelled. Magnesium carbonate. We have magnesium ion or the cation. Then we have the carbonate. This is valence 2 and this is also valence 2. In short, this one is written as MgCO3, like that. But now where we have aluminium nitrate, this is where not take things normally. Therefore, this one is written as AlNO3, then it is enclosed. It is closed into 3 like that. Why? Aluminium cation, which is valence 3, and we had a nitrate radical, which is valence 1. So this one is valence 3, and this one is valence 1. And that is why we can arrive at that. Therefore, let's meet in our next program. Thank you so much for listening.